example 2, they're asking us to find the slope of the tangent line to this curve at this point. So just like on the previous example, we are going to take the derivative with respect to x of all the pieces. So if I do it to this piece, we get 4y cubed, and since it's a y, not an x, we're going to say dy dx. Over here, we have to do the product rule. So if you remember the product rule, it's the first one times the derivative of the second one. So we just write x, and then the derivative of y is dy dx. Then we add that to the second one times the derivative of the first, which is just 1. Okay, and then if we take the derivative of this, it's just a polynomial, so we can just use the power rule. We end up with 3x squared minus 1. Okay. We can simplify this to just y. Nothing else really simplifies at the moment. And so what we can do now is we want to, we want to solve for dy dx is our goal. And so I'm going to get everything that doesn't have a dy dx onto the other side of the equation. So in this case, just subtracting y. Okay, then we'll factor out our dy dx. And then from there, divide out all this stuff. And so our dy over dx is equal to this. And then to find the specific slope at the point they want us to, we're going to plug in a 1 for y and a 1 for x. So that's going to become, let me just give myself some room. So we're going to get 3 times 1 squared minus 1 minus 1 all over 4 times 1 cubed plus 1. Okay, so 1 squared is 1 times 3 is 3, so all that's 3. Negative 1 is going to give us negative 2. And so our entire top is just 3 minus 2, which gives us a 1. 1 cubed is 1 times 4, that's 4. 4 plus 1 gives us 5. And so overall, our slope is 1/5. And now that I think about it, okay, I guess we're not done. So we didn't want just the slope. I reread the prompt. We wanted the equation of the line. So now we have all the pieces. We're just going to say y minus y1 equals m, x minus x1. The original point was 1, 1, and our slope is 1/5. So plugging this all in gives us this equation. Okay. Moving on to example 3. Okay, it says calculate dy over dx at the point pi fourths, comma, pi fourths. On this curve. So square root of 2 cosine x plus y cosine x minus cosine y. Alright. Let me just double check that's right. Cosine x minus cosine y. Okay. So, once again, it's going to be a similar process. We're just going to take the derivative with respect to x of both sides. So we have d dx of all of this and then d dx okay. So when we take the derivative of this first part, we have to remember that the derivative of cosine goes to negative sine. And so we're going to get negative square root of 2 sine, rewrite the inside, and then the chain rule says we need to multiply that by the derivative of the inside. So the derivative of just x, so I'm going to put this in parentheses, derivative of just x is 1, and the derivative of y is going to be dy dx. Okay. Now if we look at this, that's all dependent on x, so that's just negative sine x. And if we look at this one, since it has a y instead of an x, we're going to remember that negative cosine goes to positive sine. So we just say positive sine y, but then we need to multiply by the derivative of y. Okay? Now, the next thing we want to do, we're going to essentially distribute this to both of these pieces. So we have negative square root of 2 sine of x plus y, and that's times by 1, so that's good. Then we distribute this to this. We get negative square root of 2 sine of x plus y, dy dx. Okay? And then the other side of the equation is the same. Okay, our goal is to get dy dx by itself. So we just need to pick a side. I'm going to pick the right side to be my dy dx. So I'm going to add this onto this side. And I'm going to add this, because it doesn't have a dy dx, onto this side. So after I do that, I'm going to get sine x minus square root of 2 sine of x plus y equals, I moved this over so it's now positive, square root of 2 sine x plus y dy dx, and then plus sine y dy dx. Okay, from here we're just going to factor out a dy dx from each of those. And then we can divide this onto the other side. So this is our dy dx, and we need to plug in the point pi fourths, comma, pi fourths. So we're just going to plug in pi fourths for all the x's, pi fourths for all the y's, and my computer's dying, so hold on one second. Okay, so when we do that, we're going to get sine of pi fourths minus square root 2 sine pi fourths plus pi fourths, square root of 2 sine pi fourths plus pi fourths plus sine pi fourths. Okay. If you remember on your unit circle, I'm not going to go through this in detail. Use a calculator if you feel like you need to, or do a review of the unit circle. But sine of pi fourths gives us square root of 2 over 2. So all of that. Okay, and then minus square root of 2. And then pi fourths plus pi fourths is really pi halves. And let's see, sine of pi halves is going to give us 1. Down here, we have square root of 2. This is also pi halves, so that's going to give us a 1. And then pi fourths is square root of 2 over 2. Okay, so if we simplify this a little bit more, we have square root of 2 over 2 minus square root of 2. Then we have square root of 2 plus square root of 2 over 2. Alright, we're almost there. So I'm going to just get common denominators right here. So 2 over 2. And so we have 1 square root of 2 minus 2 square root of 2. So that's negative square root of 2 over 2. And then right here, do the same thing. That's going to give me 3 square root of 2 over 2. Our square root of 2 over 2's are going to cancel. And so we end up with negative 1/3 for the answer on that one.